All right, Giants, and welcome back. The first thing I'd like you to do, go ahead, pause the video, and turn to 4.5 and try these first two problems, okay? Got to multiply these complex numbers, and I want you to try it, and then once you're done, go ahead and restart the video and see how you did. All right, so remember we use FOIL. 2 times negative 4 is negative 8. Then we got negative 6i. This one will be plus 12i. And this final one is plus 9i squared. Okay, so hopefully you guys remember when we have I squared, that's the same as negative 1. So this actually becomes negative 9. We combine our like terms, negative 8 and negative 9 combine to negative 17. And negative 6i plus 12i combines to plus 6i. And this is our final answer. Okay, now the second one here, same concept. 2 times 4 is 8. 2 times 6i would be plus 12i. This one is minus 12i. And then the last one is minus 18i squared. Now this time lots is going to happen. The 12i and the negative 12i cancel. Negative 18i squared becomes plus 18 because I squared is negative 1. 8 plus 18 gives us 26, and that's our answer. All right, so today we're going to take what we did on Monday. So if you haven't watched that, you got to go back and watch that video if you weren't there Monday. But we're going to do the same concept with synthetic division, except now we have a complex zero. So right here, finding the zeros of the polynomial. First question for you is what degree is this? So hopefully you know this is degree 3, which tells us we are going to have 3 zeros, okay? So 1, 2, 3 spots. That's how many answers we need. And the good news is this first one we already have, 2 minus 3i. They gave that to us. Now, let's go ahead and set up our synthetic division. So we set that up. And we might need a little more space than normal because of the complex number. So actually, I'm going to make that a little bigger. Okay, we know 2 minus 3i is what's going to go out front. And then we have a 1 for x to the third, a negative 6, then a 21, and then a negative 26. Now, we always start the same. We drop the 1. Or drop whatever's in the lead. We multiply that. 1 times 2 minus 3i is 2 minus 3i. Add straight down, and you'll get negative 4 minus 3i. Now we need to multiply that by 2 minus 3i. However, you might notice up at the top, our warm-up problems, 2 minus 3i times negative 4 minus 3i. I already got you set up. That'll save us some time. Here is what you will get. So we know we get negative 17 plus 6i. When I add straight down, I'm going to get 4 plus 6i. And you might notice we got to multiply 4 plus 6i times 2 minus 3i. Look up here. We already did that one too. So our answer was 26. So we get 26 here. We add straight down, and the final thing is 0. So, good. We wanted a 0. That means we accomplished the first goal. Now, we know the conjugate is also a 0. So if 2 minus 3i, the conjugate of that is 2 plus 3i. Let's prove that that works. So we always start, we drop the leading term, which in our case is a 1. 1 times 2 plus 3i is 2 plus 3i. We add straight down. The 3i's cancel. We're left with negative 2 here. We multiply again. Negative 2 times 2 is negative 4. Negative 2 times 3i is negative 6i. All this will cancel, and we're left with a 0. So yes, 2 plus 3i does work. Okay, at this point now, all we have to do is set up our depressed equation here. So remember the 1 and the negative 2, that's going to become x minus 2. And remember, it was x to the third. We've done synthetic division twice, so that's why It's 2 degrees lower, x minus 2. And the opposite of that will give us our final 0, which is 2. And we are done. So, example 2, same concept. Let's start by establishing the degree. So once again, degree 3, which tells us we are going to have 3 zeros. Okay, I'm going to have 1, 2, 3 zeros. And we know that the first 0 they gave us is negative 1 plus I. Now, we have to be careful in this one because you'll notice it goes from x to the third, x to the second, x. Oh, sorry, never mind. We got to just check, but it does go in order. So x to the third, x to the second, x, and then a constant. So we're good. I misspoke. I was thinking about the next on the back. So once again, I made it too small. Let me make that a little bigger. Okay, so once again, we have negative 1 plus I out front. We have a 1, a 3, a 4, and a 2. We always start by dropping the 1, or the leading term. We multiply that, we're going to get negative 1 plus I. We add straight down, we're going to get 2 plus I. Now, unfortunately, this time we haven't solved it yet. So we need to set this up. Negative 1 plus I times 2 plus I. We multiply, negative 1 times 2 is negative 2. Negative 1 times I is negative I. 2 times I is plus 2I. And the final thing, I times I is plus I squared. Now, this becomes negative 1. So now our answer here, negative 1 and negative 2 combine to negative 3 plus I. So that comes right here. We add straight down and we get 1 plus I. And unfortunately, we do have to multiply it again. So remember, negative 1 plus I times that 1 plus I. We'll get negative 1 at the front plus 1I minus I plus I squared. And these will cancel out. This becomes negative 1. So when we add negative 1 and negative 1, we get negative 2, which is good because that tells us we did it correctly. We have 0. Now, once again, we got to take the conjugate. So this second 0 is also should be easy for us to find. The negative 1, the real number stays the same, so the negative 1 stays the same. The imaginary switches, so negative 1 minus I. So we always start the same, drop the leading term. We multiply that. It's going to be negative 1 minus I. We add straight down. We'll get a 1. Multiply again. Negative 1 minus I. We add straight down. We get a 0. That is good. That's what we wanted. So now the final thing, let's write this. And it's going to be x plus 1, which we hopefully know. All we have to do is set that equal to 0, subtract the 1. You get x equals negative 1, or you could have took the opposite. Either way, our third 0 there is negative 1, and we are done. So go ahead, flip it to the back, and now this one, you notice hopefully there is a degree of 4. Okay, so degree of 4, it's going to change the amount of zeros we have. We know we are going to have 4 zeros. So 1, 2, 3, 4 spots, 4 answers. And our first one is I. Now this one, I got ahead of myself. We need to be careful on. X to the fourth. Another way to write this would be x to the fourth plus 0x to the third. We have to have a placeholder. Plus 26x squared plus 0x plus 25. I have to add those two zeros because in standard form, when we're doing synthetic division, we need every place represented. So x to the fourth, x to the third, x to the second, x, and constant. Now, at this point, we can simply follow our rules for synthetic division. So we write 1, 0, 26, 0, 25. And we know there's an I out here. We always drop the first term. 1 times I is going to be I. We add straight down, we get I. I times I is I squared, which is the same as negative 1. So we add straight down, we get 25, which will give us 25i. We multiply again, and we get 25i squared, which hopefully we remember it's the same as negative 25, which means when we add straight down, we get 0. Now the good news is we also know negative I should work, the conjugate. So once again, we drop the 1, we multiply, we get negative I, that adds to 0, which gives us a 0 here, which gives us 25, and then minus 25i. So once again, we get a 0, so good. Negative I also works. Now here, be very careful. Here's where I think some of you might make a mistake if you're not careful. This 25 is our constant. There is 0x right here, which means it is actually plus x squared, or 1x squared. So x squared, let me rewrite that. X squared plus 25. Set that equal to 0. If we subtract the 25 over, we're left with x squared equals negative 25. We take the square root of both sides, and we're left with x equals plus or minus 5i. So right here, I'm going to put 5i, and I'm going to put negative 5i, and I will be done. Once again, be careful here. Don't put x plus 25. It's x squared plus 25, because this 0 held the place of the x, which meant this one was an x squared. Okay, so now, example 4, we got one final example. And if you want, go ahead, try it on your own. I'd love that. Pause it, try it on your own. Otherwise, go ahead, follow along with me. So once again, this is degree 4. It's in standard form, so all we have to do is look at the biggest exponent, which x to the 4th, biggest one is 4. And that means we're going to have 4 zeros. So 1, 2, 3, 4 answers. And we already know our first answer is negative 4i. Now, once again, I think it's helpful to write it out with the placeholders. If you don't need to, you don't have to, but we have 0x to the 3rd, 25x squared. There's 0x, so there's no x term. So now we can set this up for synthetic division. 1, 0, 25, 0, 144. And we got a negative 4i out front. We drop the 1. We multiply, we get negative 4i again. Add straight down, negative 4i. Multiply, we get positive 16i squared, which we know is the same as negative 16. So now if we add straight down, we're going to get 9. We multiply that, we're going to get negative 36i. Multiply again, and we'll get positive 144i squared, which means it's the same as negative 144. And so if we add down, that becomes a 0. So what we need to do next, the conjugate, which if it's negative 4i, that means 4i. So we drop the 1, as always. Multiply, we get 4i. This will cancel to 0. We'll still get a 0 there. Then we'll get a 9. 9 times 4i is 36i, which is good because that means that cancels. And we're almost done. The final thing we need to do, write this depressed equation. So remember, we've done synthetic division twice, so that tells us that this leading term will be an x to the 2nd. And so we know that it's going to be x to the 2nd plus 9, the 0x. If you want to put that in, you can, and that equals 0. So now to solve this, all you have to do is subtract 9. X squared equals negative 9. Take the square root of both sides, and hopefully you know that it's going to be plus or minus 3i. So up here, I need to put 3i and negative 3i. And I am done. So please reach out if you have any questions. Make sure you work on today's lesson, and if you have any questions, please let me know. Oops, I'm confused here is what I'm